Welcome to the Innovation Machine Shop. The Machine Shop is used for MIE class and research work. We have a wide variety of machines to accommodate a wide range of work. After training, students are allowed to use any manual machines in the shop and some access to CNC features with the help of the staff. The shop has cutting equipment and milling machines which will be used for training, as well as lathes, 3D printers, a water jet, and a laser cutter. A few helpful tips for the machine shop. Make sure you show up early in the semester so you have plenty of time to get your project done. If you show up towards the end of the semester, you could run out of time and not be able to finish your parts. When you do show up to the shop, make sure you have a few hours to work in the shop. If you show up and you don't have enough time, you could get your parts set up and not actually have time to machine it. You want to make sure you have plenty of time for setup, machining, and cleanup. Ask questions about your projects. If you're not sure what to do, if you're not sure about your design, or if it's possible, make sure you stop down to the machine shop and get our opinion first. You never want to finalize a design and then come to find out it's not possible to make down here in the shop. Think about the tools we have as well. We have standard American tools in our shop. If you have metric designs, you may need to change some features a little bit to make it possible in the machine shop. We use SolidWorks down here, so if you want to stop down and show us a SolidWorks design, that's nice and convenient. You can also send us a SolidWorks file we can look at and give you our opinion. If you have any other questions about the machine shop, just stop down and ask. This is our variable speed vertical bandsaw. Let's go ahead and turn on the light with this switch here. Now we can go ahead and turn on the machine. First, we're going to press this green button. That just starts the motor of the machine, but the blade is not yet moving. Now we need to select the speed for the machine. You'll notice we have labeled on our machine, right about 12 o'clock, steel, or harder materials. Right about 3 o'clock, we have softer materials, aluminum, plastics, and wood. On our dial, there's a little yellow indicator right on the bottom left on 0 now. We're going to twist that around for the material we're cutting. I'm going to go ahead and turn it up to about 12 o'clock. Now the blade's spinning, we can cut our material. When we're done, we're going to want to shut it back off by putting the speed back down to 0. The blade takes a second to come to a complete stop, and then we can hit the red button. While using the bandsaw, do not use your hand to brush off chips. They can be sharp metal chips that can become embedded in your hand. Also, your hand can be getting close to the blade. If you need to clean the bandsaw, first, make sure the machine is off so the blade's not moving, and use a brush to clean the machine. Take your time cleaning around the blade because it's still sharp. A bandsaw can cut most materials you'll find here in the shop. We can cut woods, plastic, and metals. Some exotic metals and materials such as glass, ceramics, and hardened steel cannot be cut on this machine. If you're unsure what material you have, please ask for help identifying it before you try and cut it. When we're going to cut our part, we turn on the machine and select the speed for the type of material we're going to be cutting. Then we're going to take our part and place it flat down on the table. We want to make sure when we cut our part, we have one hand on each side of the part pressing right through. We never want anything behind the blade. If my finger is behind the blade and I cut through my part, I'm going to continue into my finger. So one hand on each side of the blade pushing right through. If we have a very small part and we can't safely get our hand on each side of that part, we can use a block of wood. We can put the block of wood behind the part, line it up in position where we need to cut, and then we can get our hands further away on that block of wood, helping us cut it off. Anytime you use the bandsaw, make sure you take your time and pay attention to where your hands are at all times. While cutting off your part, make sure you leave some extra material. If we want our part to finish at exactly 3 inches, we need to leave a little extra to machine after we cut it. I would cut the part about 1/8 of an inch longer when I'm using the bandsaw. The guide on the machine, right here, can be raised or lowered. If we need to raise it, we use this lever here, raising the guide up, and then we can accommodate if we need to cut a thicker part. If your part isn't very thick, like this part here, we want to make sure we lower the guide back down. That gets our guide closer to our part, sturdies up the blade, making a better cut, and protects all these extra teeth, making it a little bit safer. While cutting with the bandsaw, your part should always be flat down on the table so it can't move or rock while it's cutting. That means if you have a round or odd shaped part that you need to cut, you need to hold it with something to prevent it from moving. If I have this round piece of rod right here and I try to cut it, it could spin or rotate as I'm trying to cut. What I need to do is put it flat down on the table, and with the help of this vise right here, put the vise upside down over the part and then clamp it into place, making sure it's nice and snug and it's not going to move. Then I can simply hold onto the vise and push the vise through so my part can't rotate on me. That's our variable speed vertical bandsaw. We use this machine a lot in the shop. It's very convenient when you come in the shop and you have a piece of material that's too long and you need to roughly cut to size. Again, there's a few different things going on with the machine, so if you forget or have any questions on how to safely operate the machine, before cutting, stop, come to the staff, and ask for help. This is one of our track milling machines. I'm going to go over most of the basic features on the machine so you have a general understanding of how it works. There's a lot to learn about this machine, so if you have any questions or are unsure about a certain operation or machine feature while you're using the machine, please ask for help. To turn the machine on and off, we're going to use the yellow switch located right here. We have position 0, which is off. We use position 1 to the left if the machine is in high range. We use position 2 to the right if the machine is in low range. Our milling machine is equipped with a brake. It's located right here under the on-off switch. You just lightly pull it down. I tell everyone it's a good habit to get into. The first thing you should do when you turn off the machine is hit the brake, stopping the tool instantly, making it that much safer to work around. Let's go ahead and turn on the machine. We're going to use position 1 because we're in high range. The machine's on and spinning. When we're done, if we just turn it back off to 0, the machine is off and the tool continues to spin for another few seconds. In that time, a lot of people want to reach close to their part to see what they did or measure the part, getting close to that tool bit, which is very unsafe. You never want to get close to a spinning cutting tool. Now, let's try this again, and this time use the brake like you should. Again, position 1 to turn the machine on. When you want to shut it off, back to position 0, and immediately hit the brake, stopping the tool instantly, making it that much safer to work around. Our milling machine has 2 windows indicating what speed the machine is running, depending on if you're high or low range. You need to look at the corresponding window to check or adjust your speed. High speed is in red on the right. Low speed is in left in blue. To adjust the speed, the machine must be running as indicated by the caution sticker on the front of the machine and on the adjustment handle itself. So let's go ahead and turn the machine on so I can adjust the speed. We're going to use position 1 because we're in high range. Now that the machine is on, we can use the adjustment handle to raise or lower the speed. We'll shut it off and hit the brake. What speed you need is dependent on a lot of things, such as type of tool, tool size, material type, and how solid your part is mounted. If you're unsure what speed to use, please ask for help. When we want to work on the machine, we must first check the machine to see if it's in high or low range. If the machine's in high range, we're going to turn it on with position 1. If the machine's in low range, we're going to turn it on with position 2. This also tells us what speed window we're going to be looking at. If we look at the side of our machine, we see the high-low lever right here. Right now, it is towards the front of the machine in high range. High range is for softer materials and smaller tools. If we cut harder materials or use larger tools, we might want to be in low range. To put the machine in low range, we want to push this lever towards the machine and then spin it all the way down around back. It's going to lock in a detent. It locked into the rear detent. It is now in low range. Now we can look at the low range speed window and use the machine in position 2. I'm going to go ahead and turn the machine on in position 2. We can see the tool is spinning nice and slow. I'll turn it back off and hit the brake. When we want to switch the machine into high range, we're going to use that same lever. Pressing it in towards the machine, it's going to spin around front. What you then need to do is grab the spindle right above the tool and rotate this by hand. That lever is going to pop right into place. Now you are in high range. You have to spin that spindle by hand or the gears are not yet meshed together. When you start the machine, the gears will grind. So make sure if you're going to put the machine into high range, you give that a little spin, it'll pop right into place, you're good to go. Back in high range, looking at the high speed window and using the machine in position 1, nice and fast. Back in high range. We'll shut it off and hit the brake. The quill of our machine is located right here. This makes the tool move up and down. We use this feature all the time. If I'm going to be drilling a hole, I'm going to move the drill up and down, pecking the drill into the part. If I have an end mill, the tool that's in the machine right now, I want to set the height of the end mill and lock the quill using the lock right here on the front. We just snug this lock down. Now the height is set and can't move. It's very important to make sure your quill is locked when you're going to mill something or your tool can move when you don't want it to. You could ruin your part, break the tool, or get hurt. Once you are done milling, or if you need to adjust the height, don't forget to unlock the lock by pushing it up so the quill can move freely. Forcing it to move when locked can damage the machine. Our quill handle location can be changed. If we grab the center of the quill and pull out, it disengages the handle so it can be rotated to any position. And we push it back towards the machine, it re-engages, locking it into place. We can use it from that new location. I do this to keep my hand away from the tool bit, especially if there's spinning chips coming off the tool. Or, more frequently, to just reposition the handle to a position that's more comfortable and easier to use. As we move our quill up and down, we'll see this black block inside of here moving up and down. This block moves with our quill and our tool over the threaded shaft until it hits this silver block, our quill stop lower down. It hits there, preventing our quill from going down any further. We can adjust that quill stop by carefully with 2 hands pressing the button on the side and quick adjusting it, or once we quick adjust it in roughly the right location, we can thread this and spin it up and down the shaft for finer adjustment. Now when the quill comes down, it's going to hit that stop and can't travel any further. That's a nice quick way to stop the tool at the same depth for a repetitive operation like drilling a bunch of holes all the same depth. We use this feature all the time. It's very convenient. You have to remember when you're done using the stop to move it back to the bottom so it doesn't limit quill travel when not needed. This is the vise on our milling machine. It's how we hold 99% of our work. We turn the handle clockwise to tighten, counterclockwise to loosen. When we're going to hold a part in the vise, we need to make sure it's nice and clean so there's no chips or debris underneath our part influencing how it's sitting, or on the sides of our part getting crushed into our part from clamping. We're going to take our part, put it down in the vise, snug up the handle, and then use 2 hands so it's nice and tight. Then our part is ready to machine now that it's nice and secure. If you take your part and you put it in the vise, and only lightly tighten it, it appears to be held, but if you grab this part, you can move it. If you go to machine that part, it's not held tight enough, not secure, it will move. That can damage your part, your tool, or you could possibly get hurt. So make sure your part is secure by using 2 hands nice and tight. When we want to machine a part, we take our part and place it into the vise. If it's too low, we can't reach the top and machine what we need to reach. We need to use a set of parallels to raise up our part. This is a set of parallels. It's a matching set. We want to make sure they're nice and clean. One of them goes in the back, one of them goes in the front against the jaws. Then we can take our part, put it into the vise, sitting on top of those parallels. Now we can tighten our part here, again, 2 hands, nice and snug, securing our part. Now we can reach the top of the part to machine it. While machining, you always have to keep in mind where your part is being held and where your tool is trying to reach so you don't hit anything. You have to remember, most likely you have parallels underneath your part, and if you don't, the vise is underneath your part. If you drill through your part and into the parallels, you're going to ruin the parallels and the drill, and possibly your part as well. And in this case, you may need to change to a different set of parallels that won't be in the way when the drill goes through your part, or change the setup so you don't damage anything. These milling machines are 3-axis machines. We have X, Y, and Z. X-axis moves the machine left to right. It's the longest axis. Y is in the front. Y moves the machine in and out. Z-axis on our machine is located right here. Our Z-axis handle is on a spring, so you have to push the handle in and engage the teeth. Now you can slowly move the machine up or down. You have to remember to keep slight inward pressure to keep the handle engaged. Once the height is set and you release the handle, the spring will push the handle back out so the handle is just swinging and not engaged. Our machine has locks on some of the axes. We talked about our quill lock that stops the quill from moving up and down. We also have locks on the X-axis and Y-axis. The 2 X-axis locks are located right here in the front. If the lock is tightened, it's going to snug up or lock the axis completely. If you want to move the machine, you need to check to make sure the locks are not tight. If they are, you're going to wear out the machine. The Y-axis lock is located on the left underneath the table. Again, if you're going to move the machine, you need to ensure the locks are not tight or you're wearing out the machine much faster. This is the readout on our milling machine. It keeps track of our X, Y, and Z based on the origin set by the user. These readouts are not touchscreen, so please do not try to touch the screen itself. If you want to zero one of the readings, we push X, Y, or Z corresponding to whatever axis you want to zero. I'll start with X. And then we push absolute set, or ABS set for short, on the machine. Now the axis X is zeroed. Our readout is reading in inches in 4 place decimals at 1/2,000th resolution, 0.0005 inches. A human hair is roughly 5/1000th of an inch, 0.005 inches. So we're reading 1/10 of a human hair. It's very accurate. So depending on what you're making is how critical you need to pay attention to these numbers. We don't want to be off a decimal place and have a large error, but if you're off 0.001, 1/1000th of an inch, it's usually not a big deal. So don't stress over getting that last decimal place perfect. Changing tools with our milling machine is nice and easy with the air-driven tool changer. We need to make sure we raise the quill all the way to the top, and then we lock our quill by snugging the lock downward. Now we can carefully hold onto the tool on the shank, the smooth part above the sharp flutes. We want to make sure we're not holding those sharp flutes. Now we can press and hold the out button right here. Now we have the tool and the tool holder out of the machine. There's nothing holding this tool into the holder. It simply slides right out. So you want to make sure you don't drop either one of them. When you go to put a new tool back into the machine, you must make sure you have the correct size collet that matches the tool shank, the part of the tool that you're holding. If it's not an exact match, you will damage the collet and could damage the machine as well. Once verifying the size of the tool and the collet are the same, we slide the tool into the collet the depth we would like, and we carefully hold on the top of this tool, making sure we're not holding the collet or have any skin up above the collet that could get pinched when we load the tool. Now we need to push the tool up inside of the spindle. We want to make sure we have slight upward pressure and rotate the collet around until we find the keyway. The tool is going to go up another few inches. Once the tool is up inside the quill, again, making sure we're holding the tool so we don't get pinched, we want to keep light upward pressure and press the in button for 2 seconds. Now the tool is nice and tight in the machine. For the third time, ensure when you're loading the tool into the holder, you don't have any skin that's going to get pinched up between the collet and the machine. We have a few different types of tool holders for our machines. If we're holding an end mill, we're going to be using a standard collet that looks like this. When you're using a collet, you have to make sure the shank, the part of the tool you're holding, matches the collet size exactly. If the tool and the collet aren't the exact same size, you can't use it. You're either going to spread the collet apart and damage it, or you're going to crush it trying to hold your smaller tool and damage it as well. If you're going to use a drill, you want to make sure you use an adjustable drill chuck. Since the drill chuck is adjustable, it can hold any size drill up to a 1/2 inch. For edge finding, you also want to use the adjustable drill chuck. Again, drill chuck for drills, collet holders for end mills. Edge finding is the process of locating our part on the machine to set an accurate home or zero for the machine. This zero should match the print or design of the part, so it's easy to machine the features how you have them designed and drawn out. Usually the zero is set to the top left of the part, unless it's hard to do so by the nature of the part. When edge finding, we use the adjustable drill chuck with our edge finder loaded in it. Our machine is going to be in high range. We're going to be running the machine in position 1, and our speed is going to be about 1500 RPM. Our goal is to find the edge of the part and set that edge to 0. I'm going to go ahead and use the quill to lower the tool so the bottom of the tool is below the top of the part. I locked our quill so our height can't change while I'm trying to use it. I'm going to go ahead and turn the machine on in position 1 for high range. The edge finder is the only tool you can touch while it's running, and you can simply bump this bottom section with your fingernail, kicking it off to the side, making it a little bit easier to see as you approach your part. I'm going to now start slowly moving Y-axis into the part. As we get closer and closer, it makes that edge finder look more concentric. As we get very close, I need to approach very slowly. I'm going to wait until that edge finder kicks off to the side. Very slowly going into it, and it kicked off right there. As soon as it kicks off, you need to stop moving. You're going to go to your readout, and on the axis you're trying to zero, clear that axis. Right now, Y-axis. I'm going to hit Y, and then absolute set. Now we need to verify that. So we need to back up off of our part and do it again. Again, very slowly approaching that part, waiting for that tool to kick off. Again, as soon as that tool kicks off, you stop. This time we need to look at the readout. We want to make sure that 0 we just set is again 0. If that number is larger than 0.001, you are moving too fast. You need to start the edge finding process over. If that number is smaller than 0.001, you were going nice and slow and we accurately found the edge of that part. I'm going to go ahead and raise our quill up above our part. Now I'll shut the machine off and hit our brake to stop that tool. So far, what we've done is we've set the edge of this tool on that back surface of our part and zeroed it. Now we need to account for the radius of that tool. The radius of the lower section of the edge finder we were touching is 0.1. So I'm going to adjust the machine 0.1 towards the part or on top of the part, and then I'm going to go to my readout and clear Y again by hitting Y and then absolute set. So now we have accounted for the radius of that edge finder, so the center of the tool is on the back edge of that part. Edge finding X or Y is the same process. Just make sure you're clearing the correct axis on the readout, or you'll mess up the other reading if it's already set. Once both axes are set, you can move your tool to X0, Y0, and the center of your tool should be right on the top left edge of your part. If it looks off, you may have messed up a step, forgotten to offset the radius, or gone the wrong way with the radius offset. If the tool doesn't look centered on the edge of your part, you need to start the edge finding process over and make sure it is correct. If you machine a part and your zero is off, everything you machine will be off as well. After your part is edge found in the machine, don't remove it or you'll lose your X0 and have to edge find your part again. One way around this is to use a stop on the machine to locate your part along the X axis. Then you'll be able to remove your part and put it back into the vise in the same location. This is also the way you want to machine multiple parts, so you only need to locate the first part. You can't edge find the top of your part to set Z because every time you change the tool, your height is lost. Because of that, to set your Z, you have to use the tool you're going to be machining with. Setting Z is nice and easy. With the machine off, you can come down with the quill until you very lightly and gently touch the top of your part. Holding the quill there, you go to your readout, hit Z, absolute set. Now Z is set. When you're done, raise the quill and the tool back off of your part so it is not touching. You never want to start the machine while touching your part. Touching off the tool directly on the part only works in the Z direction. These are just the basics of the track milling machine. Some of the machine features aren't covered for sake of time. This machine is a hybrid machine that has some CNC capabilities as well. If you need those features, talk to the machine shop staff and we can help you. This overview video alone doesn't replace in-person training or qualify you to use the machine in the machine shop by yourself. You must complete the in-person training and work under the supervision of the machine shop staff. If you have any questions or comments about the machines, please contact the machine shop staff. There are a lot of different situations that may arise in the machine shop, such as how to hold a part, what tool to use, or if you forget how to do things, like changing the machine into high or low range. We understand there's a lot of new information we're learning in a short time. If you're unsure, stop what you're doing and ask the staff for help. Thanks for watching.